Today I'm going to give a quick demonstration on how the object filters in ANTS Memory Profiler 5 can allow you to rapidly focus your analysis to identify objects which may be leaking in your application. You can also use them to quickly give your code the clean bill of health to avoid problems later on. So let's begin with starting the application to be profiled, QueryB. I've already specified my QueryB application as the process to be profiled and can simply click Start Profiling to begin. QueryB loads and ANTS Memory Profiler 5 is now recording the memory usage of the application. The first thing to do is to take a snapshot to use as our baseline. With that done, I then load up QueryB again and pick a database to connect to and enter a query to run it through its paces a little. We're going to use AdventureWorks today as this example. Here we have our query form, where I then put in my statement and execute the query. We can see the memory usage of the application has increased via the timeline in ANTS Memory Profiler. We now close the form, and you'll notice that the memory usage hasn't dropped. This is very suspicious. So let's take another snapshot. The results are showing that we have 802 classes. That's quite a number. One simple strategy is to use the object filters to focus your analysis on a subset of classes. Let's first switch to the class list. Now let's look at the filters we can immediately use to help reduce the number of classes that we may be interested in. Because we have taken two snapshots, one very useful filter is the Comparing Snapshots filter. From here we can see new objects, those which have been created since the baseline snapshot, surviving objects, those which were in the baseline and still exist in the current snapshot, zombie objects, objects which were on the finalizer queue but aren't any longer. Because we are currently interested in what has been created since our baseline snapshot, let's only look at the newest objects. We can see the impact that this filter has had on the bar above the class list. We now only have 580 classes and have made invisible almost a quarter of the classes that were there originally. That's a pretty good start. With the way in which memory works in .NET, we know that objects which are not being removed get promoted through generations, so let's take a look at only the objects which exist in the Gen2 heap. This hasn't had much of an impact in terms of removing more classes. Obviously a large number of the objects in our current project have been promoted to Generation 2. Another indication that we may have a problem with the current app. Because the current application makes extensive use of event handlers, and this is a very common cause of memory leaks in .NET applications, I'll apply that next to see if it has any impact. Wow, we only have 125 classes left. That's quite a decrease. Let's take a quick look down the class list. Oh, here's something suspicious. We have an instance of our query form highlighted in bold because it's a class that we have source code for. That's not right. I closed that form after the query had completed. It shouldn't be there. We can then begin to examine why by looking at this specific instance. Switching to the instance list, we can see this particular instance has over 12 megabytes of memory with the size with children column. This is quite a lot for such a small application. Next thing to do is to create an object retention graph for this particular instance. This object retention graph shows me what is still referencing our query form. Once I figure this out, I'll be able to go back into my code to break the chain of references that is keeping the query form in memory. There's a handy hint here telling me to start at the bottom and work my way up the graph until I find a reference that needs to be broken. I'll just need to break the chain at one point to allow the garbage collector to clean up everything below that. First, the graph is telling me that this system.eventHandler is referencing query form. And if we step up one more level, it's telling me that the event handler is referenced by our connect form instance. This is the form that asked me for the database connection details. In other words, the connect form is holding onto the query form via an event handler. If I look at this node more closely, I see that it's actually being referenced by connect form's foregrounded field. I can now switch to Visual Studio to begin investigating this further and break this reference to help resolve the issue. There are many more filters in ANTS Memory Profiler 5 which I have not covered, but I hope that this example has given you a feel for what is possible and how filters can aid in the analysis of even the most complicated applications.